Today we are going to discuss about change of state. We know that matter exists in three states, namely solid, liquid and gas. It can be converted from one state to another by heating or by cooling. A transition from one state to another is called a change of state. Okay, so change of state means transition from one state of matter to another. Transition from solid to liquid state is called a melting. Okay, and it usually takes place at melting point. Transition from liquid to solid state is called, the reverse process is called a fusion, and it is also called a freezing. Transition from liquid to vapor state, and it takes place at boiling point, and that process is called vaporization. Transition from vapor to liquid, it is called condensation. Transition from solid to vapor state, directly from solid to vapor state without passing through the liquid state is called sublimation. There are certain materials which sublime, camphor, naphthalene, etc. And the reverse process from vapor to solid state is called deposition. So these are some change of state normally taking place in solid, liquid and gas. Now, to study the change of state on heating or cooling, let us perform an activity. So, if you take some ice cubes in a beaker, so these are some ice cubes taken in a beaker, note the temperature of ice. This is a thermometer to measure the temperature, and the thermometer shows 0 degrees Celsius. Now, start heating it slowly on a constant heat source. Okay, this is a heat source in order to give constant amount of heat. Note the temperature after every minute. Continuously stir the mixture of water and ice. Ice starts melting. Okay, but if you note the temperature, we will observe no change in temperature so long as there is ice in the beaker. Okay, so now the change of state is taking place. Ice converts from solid state to liquid state, but we can see that the temperature remains constant. In this process, the temperature of the system does not change even though heat is being supplied. We are applying the quantity of heat, but the temperature remains constant as long as there is ice in the beaker. When the full amount of ice gets converted to water, then only the temperature rises. So as long as there is ice cubes in the beaker, temperature remains constant. Okay, so what happens to the quantity of heat? The quantity of heat supplied is used for change of state from solid state to liquid state. So this is the experiment. Okay, so during the change of state, there is no change in temperature. Here the heat supplied is being utilized in changing the state from solid state, that is ice, to liquid state, that is water. After the whole amount of ice gets converted into water, again if you continue further heating, we can see that the temperature begins to rise. When the whole amount of ice gets converted to water, again if you continue heating, we can see that the thermometer shows reading from 0 degrees Celsius upwards. The temperature keeps on rising till it reaches 100 degrees Celsius. Again at 100 degrees Celsius, it again becomes steady. Now the heat supplied is used for change of state from liquid to vapor state. Until the whole amount of water gets converted to water vapor, again the temperature remains steady at 100 degrees Celsius. That shows the heat supplied is used for change of state from liquid state to which state? Vapor state. Okay, liquid state to vapor. So during the change of state, there is no change in temperature. When whole amount of ice gets converted to water and the whole amount of water gets converted to vapor, the temperature remains steady. So this shows that during change of state, there is no change in temperature. Thus, during change of state, temperature remains constant. Now, where does the heat supplied go during transition? So, the answer is it is used for change of state from solid to liquid or liquid to vapor or from one state to another. Thus, the heat supplied remains hidden somewhere or it remains latent somewhere. Okay, hidden or latent, and that heat is called a latent heat. So, what is latent heat? It is the latent heat of a substance is the amount of heat required to change the state of unit mass of a substance. Okay, so amount of heat required during change of state is called latent heat, and the heat required to change the state of mass m of a substance The quantity of heat required to change the state of m mass of a substance is given by Q equal to m into L, where Q is the quantity of heat required during the change of state, m is the mass, and L is called latent heat. L is called latent heat. And how will you define latent heat? It is the quantity of heat required to change unit mass of a substance. If there is no change in temperature, the quantity of heat required is given by Q equal to m into L. In the last section we have studied during change in temperature, the quantity of heat is given by Q equals ms delta T. If there is no change in temperature, definitely we can say that some change of state is taking place there, and the quantity of heat required during change of state is given by Q equal to m into L, where Q is the quantity of heat required, m is the mass of the substance, and L is called latent heat. And what is the unit of latent heat? Unit of L is L equal to Q by m, isn't it? So joule per kilogram. So the unit of latent heat is joule per kilogram. Clear, children? Depending upon transition from solid to liquid or liquid to vapor, there are two types of latent heat. Number one, latent heat of fusion. It is the amount of heat required to convert 1 kilogram of a substance from solid to liquid at its melting point. Okay, that is called latent heat of fusion. So 1 kilogram of ice is converted to 1 kilogram of water, and it takes place at melting point 0 degrees Celsius. So what is the quantity of heat required during that process is called the latent heat of fusion. It is the amount of heat required to convert 1 kilogram of a substance from its solid state to liquid state at the melting point. And second one is latent heat of vaporization. It is defined as the amount of heat required to convert 1 kilogram of a substance from liquid state to vapor state at its boiling point. That is called a latent heat of vaporization. Clear, children? Latent heat of fusion of ice is 3.33 into 10 raised to 5 joules per kilogram. So what does it mean? It is the amount of heat. This much is the amount of heat, that is 3.33 into 10 raised to 5 joule is the amount of heat required to convert 1 kilogram of ice to water at 0 degrees Celsius, because melting point of ice is 0 degrees Celsius. So 3.33 into 10 raised to 5 joule of heat is required to convert 1 kilogram of ice to water at 0 degrees Celsius. Clear? Now, latent heat of vaporization of water is 22.6 into 10 raised to 5 joules per kilogram. It means that 22.6 into 10 raised to 5 joule of heat is required to convert 1 kilogram of water to 1 kilogram of water vapor at 100 degrees Celsius. So that is the significance of latent heat of fusion and latent heat of vaporization. Now we can consider a plot of temperature versus heat energy for a quantity of water. Let we have taken some ice at minus 20 degrees Celsius. Let this is minus 20 degrees Celsius. Okay. If you are giving some amount of heat, we can see the temperature rises until it reaches 0 degrees Celsius. Okay. 0 degrees Celsius ice. Again, if you are applying the quantity of heat, we can see that the temperature remains constant until the whole amount of ice get converted to water. So here it is 0 degrees Celsius ice, and here it is 0 degrees Celsius water. So this takes place, the change of state from ice to water. So during this change of state from ice to water, what happens to temperature? Temperature remains constant. We are applying the quantity of heat, that is called a latent heat of fusion, but the temperature remains constant. Clear, children? So until the whole amount of ice convert to water, temperature remains 0. Now again, if you are giving the quantity of heat, what happens to temperature? Temperature increases until it becomes 100 degrees Celsius. This is 100 degrees Celsius. Again at 100 degrees Celsius, temperature remains steady. So this is 100 degrees Celsius water, and here this is 100 degrees Celsius vapor. So this takes place, the change of state from water to water vapor. So until the whole amount of water gets converted to water vapor, temperature remains 100 degrees Celsius. Clear? So during this process, heat energy is supplied, but the temperature remains constant. That means the quantity of heat supplied is used for change of state from water to water vapor. Okay, so during this change of state also temperature remains constant. Again, if you are given the quantity of heat, the temperature of vapor increases to some 110 or 115 degree Celsius. So from the graph it is clear that during change of state temperature remains constant. And here this represents solid state, that is the ice state, and here this represents pure liquid state, and here this represents pure vapor state. Okay. Now we can discuss a question. Burns from steam are usually more severe than those from boiling water. Latent heat of fusion of water, that is 22.6 into 10 raised to 5 joule per kilogram, that you know. So that is 22.6 into 10 raised to 5 joule of heat is required to convert 1 kilogram of water to vapor at 100 degrees Celsius. Therefore, the steam at 100 degrees Celsius carries this much energy more, that is 22.6 into 10 raised to 6 joule per kilogram more than water at 100 degrees Celsius. So, if you say that 1 kilogram of steam has 22.6 into 10 raised to 6 joule heat more than 1 kilogram of water at 100 degrees Celsius. So, steam has more heat content than water, and hence the burns produced from steam are more severe than those from boiling water. Calculate the heat required to convert 3 kg of ice at minus 12 degrees Celsius kept in a calorimeter to steam at 100 degrees Celsius at atmospheric pressure. Specific capacity of ice is 2100 joule per kilogram degree Celsius. Specific capacity of water 4186 joule per kilogram degree Celsius. Latent heat of fusion is 3.35 into 10 raised to 5 joule per kilogram. Latent heat of vaporization 22.6 into 10 raised to 5 joule per kilogram. So, these are the values given. Here we have to calculate the quantity of heat required to convert 3 kilogram of ice at minus 12 degrees Celsius. So, ice at minus 12 degrees Celsius to steam at 100 degree Celsius. At 100 degree Celsius. So, here this can be calculated in different steps. First, we can calculate the quantity of heat required to convert minus 12 degrees Celsius ice to 0 degrees Celsius ice. That is the first conversion. If minus 12 degrees Celsius ice is given some amount of heat, it first convert to 0 degrees Celsius ice. Clear? So, heat required to convert minus 12 degrees Celsius ice to 0 degrees Celsius ice, that quantity of heat, let it be Q1. Here there is change in temperature. If there is change in temperature, the formula for quantity of heat is Ms delta T. Clear? So, it is equal to mass. Mass is given as 3 kilogram into specific capacity of ice. Here minus 12 degrees Celsius ice to 0 degrees Celsius ice. Specific capacity of ice is 2100. What is the change in temperature? Minus 12 and 0. So, change in temperature is 12 degrees Celsius. So, the final answer is 75600 joules. Next is the quantity of heat required to convert 0 degrees Celsius ice to 0 degrees Celsius water. Okay, if 0 degrees Celsius ice is given about quantity of heat, it first convert to 0 degrees Celsius water. What is the quantity of heat required? Here Q2 equal, here there is no change in temperature, only change of state is taking place. So, the quantity of heat is given by Q equal to ml. Here ice to water, so LF. Okay, latent heat of fusion from solid state to liquid state. So, substituting M equal to 3 kilogram, latent heat of fusion is 3.35 into 10 raised to 5, and the answer is 1,005,000 joules. This is the quantity of heat. Now, the third step is heat required to convert 0 degrees Celsius water to 100 degrees Celsius water. Okay, so second step is 0 degrees Celsius ice to 0 degrees Celsius water. If again quantity of heat is given, 0 degrees Celsius water becomes 100 degrees Celsius water. The quantity of heat required is Q3 equal, here there is change in temperature. So, the formula is Ms delta T is equal to mass is 3 kilogram. Here water, no, so specific capacity of water is 4186. What is the change in temperature? 100. So, the answer is 1255,800 joules. Now, next process is the heat required to convert 100 degrees Celsius water to 100 degrees Celsius steam. Okay, 100 degrees Celsius water to 100 degrees Celsius steam. So, here there is no change in temperature, but there is change of state from water state to steam. So, since there is change of state, the formula is Q equal to ml. Here water to steam, so latent heat of vaporization LV. So, mass is 3 kilogram, latent heat of vaporization is 22.6 into 10 raised to 5, and its answer is 6768000 joules. Okay, so these are the different steps of quantity of heat. First quantity of heat is given, first minus 12 degrees Celsius ice converts to 0 degrees Celsius ice, the formula is Ms delta T. Again quantity of heat is given, 0 degrees Celsius ice becomes 0 degrees Celsius water. Here there is no change in temperature and hence there is change of state taking place. So, the formula is ml. Now, 0 degrees Celsius water to 100 degrees Celsius water, here change in temperature, the formula is Ms delta T. Now, 100 degrees Celsius water to 100 degrees Celsius steam, no change in temperature, so formula is ml. Now, what is the total quantity of heat required to convert minus 12 degrees Celsius ice to steam at 100 degrees Celsius? So, total quantity of heat is Q equals, we can add all the quantity of heats. So, Q1 plus Q2 plus Q3 plus Q4, and after simplification we will get the answer as 9.1 into 10 raised to 6 joules. So, this is the quantity of heat required to convert ice at minus 12 degrees Celsius to steam at 100 degrees Celsius.